Hi, I'm Steve Shaughnessy, and welcome to the Popular Woodworking Shop. I'm going to start a new project today that should both be fun and a good learning experience. This isn't a woodworking project. No, I'm going to restore an old vintage woodworking machine, and it's a classic. What we have here is a very early model Delta Unisaw. By checking the serial number, I learned this saw was manufactured in 1944. Just think of that. This machine dates back to World War II. My goal is to get this machine in good working order so that it could provide years of service in a shop just like yours or mine. So let's get started. The first thing we're going to do is just generally evaluate the condition so we know what we're getting into. Overall, the paint finish on the cabinet doesn't look bad. Not much rust. Could stand a good cleaning. Just look at this cabinet door. I just love that Art Deco Delta logo. Man, is that great. I'm not sure if I want to repaint the cabinet or just clean it up. I sort of like the shop-worn paint. It gives this machine even more personality. When I bought the machine, it came pretty complete. We have the fence, the miter gauge, the table saw insert, although it's in bad condition. We've got the motor, and we've got the switch. Two things are missing. One is the blade guard. I've got a line on one, so I might be able to replace it. The other thing that's missing is the motor cover. And I understand those are really scarce. But I'm thinking of building one and incorporating dust collection in it. You know, in those days when this was new, they didn't even think about dust collection. Okay, let's check out the fence. As you can see, it's not a Biesmeyer. I can also tell just by looking right away here, there's a knob missing on this here, which was used as a micro adjustment. This lever locks the fence in place by tightening down a hook back here on the rear rail. This screw here adjusts the tension for the hook, and these two screws here adjust the parallelism for adjusting the fence relative to the blade. But I just wonder how straight this fence is. I have a straight edge here. Let's take a look. Hey, it looks pretty good. You know, I'm going to add a sacrificial fence anyway. So when I put that on, I know we'll be in good shape. We'll have a good piece of equipment here. So let's look at the top. Clearly it has some surface rust, and I think this is the worst of it right here. It's not pitted though, so we ought to be able to clean it up really well. So let's throw a straight edge on the top and see how flat this thing is. I mean, after all, it is over 60 years old. Looks really good there. Let's check this side. And that is really flat. Let's check across the front. Oh, well, these wings are way out. But you know, those are easily adjusted. So we're in good shape. This top is in really good condition. And let's check out how the hand wheels operate. You know, we want to be able to raise and lower the blade and tilt it as well. Let's see what shape they're in. Well, that's pretty smooth. I like that. How about the tilt? Yeah, I'm liking this saw a lot already. You've probably been wondering about the motor. I took it out for inspection. Just look at this beast. I actually put it on a scale. It weighed in at 84 pounds. From what I've read, it's referred to as a bullet motor because of its shape. But here's what makes it unusual. This is a repulsion induction motor. From what I understand, it was used before the capacitor start induction motor became common. A repulsion induction motor is ideal for low voltage conditions, meaning 120 or 240 volt electric. It provides high starting torque and smooth running. I haven't powered this motor up yet, and I'll show you why in just a minute. but I'm really interested to see how this baby runs compared to modern motors. And here's the original switch. No, it's not a magnetic switch, and that could be considered a safety issue, but I really like the look of it. Here's the original wire that came out of the switch box and went to the plug. You can see how stiff it looks. Here's one of the cracks, and there's another one down here. I knew this had to be replaced. Okay, now this wire left the switch box and went to the motor. You can easily see it's even in worse condition. Cracks everywhere. And look at this, bare copper. That's where the wire connected to the motor leads. Now, it wasn't all that bad when I took it out, but this was an accident waiting to happen. So I've replaced the original wiring, and while I was at it, I put in an upgrade. When this saw was made, the ground wire was not part of the plug connection. The motor was grounded to the cabinet. I've added a grounding wire, and you can see it right here. And I've connected the motor wire leads so that the motor will run on 220-volt current. It can also run and be set up on 120-volt power. Now let's go back and look at the switch again. So I've removed the switch cover so we could take a look inside. I simply reconnected the electrical wires to the switch as the old ones were when I took them off. And here's that green ground wire. It's not enough to connect just the motor to the ground, but the cabinet should be connected and grounded as well. And then all of that has to be tied to the cord that goes and gets plugged into the wall and grounded at the receptacle. Well, that's about it for this episode. Next time, we're going to tear the saw down, remove the top, take off the fence guide bars. We're going to look at the trunnions. We're going to look at the arbor. And you know, I have a sneaking suspicion that we're going to have to take the bearings off the arbor and replace those. That'll be a chore. See you next time.